Hello, Professor. My name is Edgar Paulari with student ID 101462578. In this assignment, I will be demonstrating how to detect and reduce overfitting in a CNN trend on a fashion MNIST dataset using Keras and TensorFlow in Google Column. This is my name. Then I use the prints to bring my name. Then if I run this cell, I have this cell that run. Uh, and I begin by plotting the fashion MNES data set from Keras data set contains 6,000 training images and 10,000 text images, each of 28 grayscales, which is this. Then once I run this cell, so it's going to give me um, the, the download data set. After loading, then I normalize the pixel values to be between 0 and 1 by dividing by 255, which improves model. Then the congruence, then I reshape the images to add the channel dimension from 28 by 28 to 28 by 1, because the curved 2D layer expect a 3D input, right? So finally, I split the train data into training validation. I did training validation set using skip length train test split function, setting aside 20% for validation to verify pre-processing work I display in the first image with its label, in case label song which I present is sneakers, right? This is label song that was actually presenting a sticker. So once this, so I have it as label song that actually shows some, like, it's a sneakers anyway. Then from the tension areas, then I consulted its basic CNN model using Keras, which includes two 2D layers with 64 filters and relu activation, and a flattening layer to convert 2D features into the 1D, and a dense layer with 256, right? So that is actually what I did here, and a dense layer too. So then I compiled the model using Adam Optimizer Plus categorically cross tuning as the loose function and tracked accuracy. And I trained the model for 20 echoes, which is what I did here. So I know once I run this, it's gonna give me some time before it loads, right? Because it's kind of overwriting, that's why. So I trained the model for 20 epochs and monitoring train and validation accuracy and lose. As you can see, the training accuracy increased steadily, but the validation lose flattened and even grow slightly. This is a sign of overeating. So there was actually an overeating here. Mm. Then I plotted a graph because I plotted the training and validation loss over a approach, right? So as shown here, the training loss drops smoothly, but validation loss function remains higher. Classic overeating behavior. This model is kind of learning the training data very well, but struggles to generate to unseen data, right? So yeah. And so I do the layer density derivation. To this encourage model to keep weight small and generate better. I also apply dropout of 50%, which is 0.5, right? Which is 0.5. Dropout normally disables half the neutrons during training, which helps prevent the network from relying too much on any single feature, right? So I also introduce data augmentation using the image to artificially expand the data with new variation. I configure a rotation and zoomer. So this transforms this transform the fly while training, right? I then display a three times three grid agreement image to visualize the effect rotated zoomed to recognize as the same class, right? So I have all the labels, right? I have the bell trees and everything. And yeah, and I demonstrate so the thing that I just did was just I just tried to show more of the labels and everything. So and this I demonstrate writing using a deep CNN on fashion mist and visualize the issue using loose accuracy plots. I then applied L2 regulate regularization dropout and data argument. These techniques significantly improve generalization like generalization. That is everything I did for the assignment for. And thank you so much.